And welcome to this fourth tutorial on today's lesson. We're going to look at four more problems involving inverse trig. Let's look at these three first. The first problem, we have the tangent of the arctangent. The second problem, we have the inverse sine of the sine. And in the third problem, we have the cosine of the inverse cosine. Now, when you're first looking at these three problems, you might say, well, these are inverse operations, so they should undo each other. The tangent of the arctangent should undo each other, and these two things should cancel out, and you should be left with the -5. And you'd be correct. Similarly, as the square root of something squared would cancel out, or multiplying by 3 and dividing by 3, since they are inverse operations, they should cancel out. These inverse operations should cancel out. Now, if you did that with all three of these problems, you'd only get one of them correct. Now that's the main question. The only one that you'd actually get correct is this tangent problem, part G. -5 is the correct answer to this. They do undo each other, and -5 would pop out. Here, they will undo each other, but the answer will not be 5 pi over 3. Here, they will undo each other, but the answer will not be pi. So we have to talk about why not. Well, let's look at this problem. I'm going to draw a picture of the unit circle again. Let's talk about where 5 pi over 3 is. 5 pi over 3 is all the way right here. That's where 5 pi over 3 is. Can you tell me why now this cannot be the answer to this problem? Well, 5 pi over 3 is too big. 5 pi over 3 would be all the way around this way to get to the angle, and that is too big. We're supposed to go the shortest way to get to these angles. Remember, the inverse sine, and this is involving the inverse sine, involves just this part of the unit circle, from positive pi over 2 all the way to negative pi over 2. This angle needs to be called negative pi over 3. So you'd be correct in determining that these two operations will undo each other, but you still have to be careful that the angle or the value that's left here makes sense for our inverse sine. And inverse sine must be in between negative pi over 2 and positive pi over 2. So this angle, the shortest way to get there, is called negative pi over 3. We're not going to go all the way around. That's too long. So that's why this one would be negative pi over 3. So then you might be really confused, because on this one, if we draw the unit circle, you might say, okay, well, inverse cosine is what we're dealing with, and pi would be right here, so why can that not be allowed? Well, the trick in this problem is this part of the problem doesn't even make sense. Inverse cosine of pi, I believe we looked at that in a previous tutorial. This doesn't make any sense because pi is a number that's bigger than 1. And the biggest that cosine could possibly be is 1, so there's no way that it can be pi. So this part of the problem didn't even exist to begin with, so therefore the entire problem is nonsense and does not make any sense. Now, if I extend this problem and make part J and just switch around the symbols and say inverse cosine of pi, you see how I switched the symbols here? Instead of cosine of inverse cosine of pi, I did inverse cosine of pi. Yes, these two symbols will cancel out again, of course, because they're inverse operations, and what will be left is pi, and that does make sense. So watch out when we're combining the two operations together. Yes, they will undo each other, but what has to remain must still make sense according to our original notes. We have one final problem to look at. Let's say we're combining two different trig functions. The tangent of the arc cosine of 2/3. Well, there's actually two things going on in this problem. First of all, the tangent and arc cosine will not cancel away. They will not cancel away. And also, 2/3 doesn't even ring a bell in our unit circle. This is a perfect triangle problem. And we've done this before as well. When it's not a unit circle value, so we don't have the unit circle picture to look at, we just draw our own picture. Remember this inside, I'll deal with the tangent in a minute. The arc cosine of 2/3, it's talking about an angle. and it's the angle whose cosine is 2/3. Now, I don't know what that angle is, but I can draw a picture of that angle. So let's just draw a picture of that angle. I'm going to pick the first quadrant. So I'm just going to draw a little triangle in the first quadrant, right triangle, always made to the x-axis, hypotenuse coming out of the origin, so it's an angle in standard form. Here's my angle. Again, I don't know what this angle is, but as long as I put the 2 here and the 3 here, then the cosine of this angle is 2/3. Simple. I drew a picture where an angle has a cosine of 2/3. Now what I want is the tangent of that angle. And in order to do the tangent of this angle, I need opposite divided by adjacent. So all that's missing is this opposite side. So I can do some quick Pythagorean theorem. I'll call this side y, since it's in the y direction. And I'll take 3 squared is equal to 2 squared plus y squared. So 9 is equal to 4 plus y squared. I'll subtract my 4 and I'll get 5 is equal to y squared. So therefore y is equal to, well, plus or minus the square root of 5, but I'm going to pick the positive one since of course we're going upward. So now I have the opposite side. So again, I don't know what this angle is, and I don't need to know. I know I have the tools to figure out this angle because we've already solved triangles, but I don't need the value of this angle. All I need is a picture of it where the cosine is 2/3. And having those two sides of a right triangle, I can find the missing side, which in this case is square root of 5, and now I can find that the tangent of this angle is this opposite square root of 5 divided by this adjacent 2, and the answer is square root of 5 divided by 2. So we'll practice more with these problems where we have to set up a triangle, find a missing side, and then go and find one of the other trig ratios for that. Thanks for watching this final tutorial, and we've got a lot of practice to do in class. And remember, we've got our quizzes at the end of that practice in class. So be prepared for the unit circle drill quiz and for our inverse trig quiz. See ya.